All right, cool. We're live. I mean, we don't really have an agenda, so we're just kind of chilling. Um, but we figured why not chill publicly because that's that's never come back to backfire on
Oh
anybody
no.
in their career. But no, what's up, Sarah?
I have Twitch open in another window. Holy crap. One
Oh,
second.
I've been told, or according to StreamYard, Twitch has an outage right now, which I went onto Twitch and was like, seems fine to me. But
Well, I had it muted, but apparently the mute doesn't carry when a new stream goes live.
it's
So
like they don't
it's
care
not.
about your mute. Either way, I
But
think we're both on YouTube and on Twitch because StreamYard, it's a thing, uh, not sponsored. But I wanted to see if I could get the let me get Edge. This stream brought to you by Edge, the edgiest of the browsers. Uh, let's see.
uh,
I want to see if this works now. Oh yeah, I need to do just a window. That window. Okay. Okay, cool. Yeah, so we have a browser window now. So we were talking a little bit about like PyJonas things,
mhm.
and yeah, I need to go handle that. What's been going? You've been working on like Teams bots and stuff. How's that going?
um, yeah, or I think I was working on a Discord one. I did hook up. It seems like I tried some Power Automate stuff to try and get some of those RSS feeds to make nice. Basically for tracking when people post questions on Stack Overflow.
Okay.
Turns out there's actually a official Stack Overflow bot, which I tried to add, but then when I tried to authenticate with my Stack Overflow account, it just said an error has occurred.
So you're telling me that we don't have to build it, but we have to build it? That's what I'm hearing.
Well, I feel like at least one other person should try adding it and authenticating, just
Oh,
in case I am cursed. But
try and make it work first. Don't just assume things need to be built from the bottom up. Okay, I mean, I get that. That sounds like a reasonable compromise.
let's just go back to first principles. Let's start
Yeah.
implementing the bootstrap for the silicon. Yeah. So you have the same window that I just had open. Um, yeah.
Yeah.
So what?
By the way, hi everybody. Say hi. That
Hey,
way,
everybody.
we're so I know this is like all my channels and stuff. So Sarah, like, take a couple of seconds to let people know who you are. Even though if you don't know who Sarah is and you know who I am, I feel like that's a disservice to yourself. So yeah.
Well, hey everybody. My name is Sarah Kaiser, pronouns she, her, and yeah, I'm also a Python developer advocate at Microsoft, kind of focusing on the scientific Python space. My background is in quantum computing, and I've been using Python to do all kinds of things from lab control to running demos, data analysis, ML. So um, I really get excited when I learn about all these cool actual like computer scientists develop tools that actually mean you don't have to build things from scratch. So I always start by just Googling what I want and then seeing if someone's already done it.
This is so wild because I'm the polar opposite. I just assume that no one's ever done it until I go to pip install something and then I see that someone's already done it, and I'm like, this is great. And also verifies that there are no such things as new ideas. Um, I mean, even like the project that we're working on, ultimately, it is like this idea of like how do we work on things that are fun while also making them businessy enough to justify working on them? I mean, oh, sorry, I said the quiet part out loud. How do we work on things that showcase and leverage all of the functionality and tools of? See, this is what developer advocates do: is we say the thing, but we say it in a way that makes everybody happy. Um, but yeah, this project. I know you mentioned that you were probably going to be taking a look at it as well. So I was like, I'll throw it up on the screen. I'll start, figuring out a couple of more issues, or maybe I can submit a few PRs to this. But yeah, PyJonas, it's an idea that I had for a few years, and then uh, Sarah was introduced to the picture and actually knowing how all this stuff works. So that it was
I'm
like,
just gonna put a little asterisk there.
yeah, it's like I just like playing video games. Sarah actually does data science and stuff, so like it made more sense to actually work with someone, and it's really cool because I don't have a lot of experience working like on coding projects as a team. Like even within like my day to day now, it's like I've got like 4 or 5 projects that are all, I did this thing, here's the repo, if you want to do something with it, feel free. But ultimately it's kind of mostly just me working on it. And then this is kind of like the first project where, doing like pull requests on my own repo, not working in main, like all of these things that you're supposed to do, but you never do because there's never anyone to tell you not to.
Totally. And I kind of have a lot of the same experience, like whether you're kind of doing research where mostly you've got your own project, your thesis or your postdoc stuff you're working on. Maybe you can coerce some undergrads or interns to help you. Certainly your advisor is probably too busy too. But then, yeah, a lot of the other consulting and or kind of engineering things, it's kind of lonely. So I'm excited to actually hang out and work on something together because I spent a lot of time last night. I really wish I had seen your message about working on the bot because app service deployments are fun.
it would have saved me a rabbit hole that is NASA firms data that, oh man, I sent like output logs to Anthony, and it was like, okay, I started my Azure function deploy at this time. Okay, it finished at this time, and we're like, why is it taking so long? And then like the end result is just like you're having to import like almost half a gig of Python of modules, which is like, yeah, that's kind of a lot. How do we not do that? And the end result is ultimately like I'm gonna have to like migrate away from using ArcGIS. And it's sad because like I want to do it and I know how I'm going to do it. And I want to do it like right now, but also I know that we've got like so many things coming up that I'm just like, yeah, this repo is getting used in a couple of spaces, so I should probably just leave it alone for now, and then just start like cataloging everything. But we were talking about the idea of like going through all the Azure functions. I literally like went down the list and was like, oh, I could do this. Oh yeah, then I could also do this other thing. Oh, I could tie this to like a Twitter account and then like send a tweet of like the world on fire, basically, because that's what happens when you look at fire data. Your in opinion is just the world is on fire.
It's just a bot that like every day just tweets, it's like, is the world on fire? And it just replies with yes.
Is there still a fire on the planet? And the answer is yes. Actually, that's kind of funny because we do this thing with my daughter called water check, where every time we shout water check throughout the house, everybody has to go grab a water bottle and like drink water. And I'm like, this would be, you could do like a fire check and it just immediately goes like, is there a fire on the planet somewhere? The answer, yes. Okay, cool. And it sends it back.
Yeah, you just tag it in somewhere and it just replies yes.
When you tweet to fire check, it just always, it's not even programmed to look, it just responds with a yes because it knows.
While true, reply yes.
So actually talking about this project, one of the things that we were thinking about a lot was kind of like, how do we keep this in scope? And I know that you've been doing a lot of work on the data modeling side, and I've been working on other projects. But
I've been doing some of that too, but
yeah. one of the things that I mean, and like, yeah, I think I literally added like nothing in here. Oh yeah, no, I added like a couple of like modules of like not even like, hey, do some stuff here, but more of like, here are some of the things that we need to be thinking about is like, how do I capture from camera? How do I capture from a device, from a file, or from URL? I should probably explain what this means. PyJonas is a classic Tetris coach. And I was going to show that. Actually, hold on. I think I can still. How do I loop? I'm gonna do this. And then I'm gonna change my camera to this. Then I'm going to hit the button and nothing worked because, of course, in that case, I'm just going to not do that then. Oh, wrong camera. Wrong camera. There we go. Oh, still the wrong camera. There we go. Yeah, but I have a NES over here. Boom. I thought it was plugged in. It may not be. Where does this cable go? Actually,
Is this stream just going to be you playing Tetris for
no,
inspo?
not at all. Not at all. That's a different stream. Follow me on Twitch for that stream. But it is the idea is if let me turn that off now. If I'm playing Tetris here and pushing it to a screen somewhere, we should be able to capture that like stream of information. And the fun thing is everyone wants to do like a Twitter bot or like a Tetris like playing bot or beating people bot. I just want a subtle coach. Like I just want someone to be like, yeah, you see that there? That was probably right there. That was your problem. And it's really cool that we have kind of two approaches that we want to take to this. One of them being, hey, how do I get like how do I get the statistical best move, and how do I match that with reality of that video games are very often not about statistics. Like I think the Han Solo reference, like never tell me the odds, like that's kind of how people play Tetris and people play classic Tetris. And this idea in many things that developers do is we want to kind of go beyond that and say like, how do we build this out as a system, but how do we also expand on it so that it's usable by all the people playing different versions of Tetris and different types. But that means we have to start somewhere, which is kind of where we are now. So now that everybody's caught up, we're going to be talking a lot about that. And if you have questions, throw them in the chat and we'll be happy to chat about it. So, but yeah, wait, is this my, oh yeah, ignore that. I don't know why the pull request is still there. So like we have this whole new project and I was wondering kind of from you, like Sarah, how is this what you would do with like a new project, or is this like over engineered, under engineered? Like
I think I start almost every project by just starting a Jupyter notebook.
okay.
And if you look, I think I have a branch here or maybe a fork. I'm not sure.
I see no branches.
Okay, so it's probably on my fork. I can see if I can push it. But basically, it's always basically called Scratch. I buy Jupyter notebook, and this one I could try and send you a live share.
You can, so you can share. I can stop my screen and you can share yours. That's totally cool.
That might be easiest because I've been adding some stuff. Share screen. Okay, I appreciate the tips. There we go. Question mark. Can you see it?
Yeah. Throw it on here.
Oh, there we go. Cool. Let me bigify it here. Yeah, so I took that approach after we kind of first talked about this. But basically, in my mind, there's, I think roughly 3 different tasks for what we want to do.
Okay.
Kind of the one that you were talking about, and the first one that I just wanted to tackle here was how do we take an image, like I'm basing it off of a single image. Obviously, we can turn that into processing on a video stream. Not too bad. There's tons of good Python packages for that. So, given a still, how do I basically capture the information represented in that screen cap? So that includes things like the state of the board, that being kind of like the most critical. Nice to haves, I think, are like precisely. So like I'm thinking the board is effectively, it's a grid, it's a fixed size, and basically I just want to know where there are minos. I'm not sure, and this was kind of a question I had for you, which was, do I need to know effectively the color of the remaining minos? Or like, because isn't it purely like, once it's placed, does that matter? That's a question.
The color of the minos once they're attached to the board.
Mm-hmm.
Yeah, no, I mean, no. I think the actual placement of the minos, like where it's placed, is probably more important than the fact that it is placed, which is, that's a thing. Yeah, this is fine.
Yeah, so basically, I have some familiarity with OpenCV. Thank you.
Yeah.
Good job, Sarah. So yeah, like I start by putting some notes here, kind of like rough steps. First, we have to kind of ID where the board area is. Some of the different game modes, you see at least one piece on deck. I know sometimes you see more than one piece on deck. Maybe that's maybe that's information our model needs to know. Maybe it's not. I mean, it certainly needs to know the piece that's going to be placed, but knowing like what's the next one on deck, maybe.
That makes sense to me.
Actually, probably, but I'm putting that in the not critical path part first. So yeah, I think we don't, maybe we don't actually need to ID or track what piece is in. Oops. I've got my keybind, so we can just. We don't need to keep track of what piece. So what I've been doing here was actually trying to use different color processing techniques in OpenCV, using different color filters and stuff like that to basically parse out and find. So like do something where you grayscale it, set a threshold based on a particular color filter and say, all right, that's where that piece was. But yeah, that was kind of a rabbit hole that I didn't really need. What I really want to be able to do after finding where the board is in the screen cap, which I think a reasonable, again, I think I was being a little over ambitious when I looked at this the first time. Not a surprise.
That's my favorite level of ambition. It's overly ambitious.
Well, it's just you walk in and you're like, oh, I'll just go like, I've seen this kind of stuff in tutorials. It'll be easy. And then just like 11:30 at night, goddamn, find the pieces. So I think for the purposes of our MVP, I am just going to say that we know the region. So if someone is playing, like I have some captures like that you took earlier of playing, I'm just gonna like auto crop out the part of interest. I'll crop because as long as this is digitally captured, those shouldn't move. So I'm not gonna worry about trying to find anything else in this space.
So one of the things that we can do is we can add that as a constraint of that. Hey, this is always going to be played on a viewing area of like 1920 by 1080, which means that this part of the board will always be here. This part of the board will always be here. Actually, even
you can't see
the Nintendo has here. I've already flipped the switch to say like now it is always in 1080 mode. So from there, I think that's safe to say is like we don't have to necessarily detect those areas. Do you want me to throw this back up?
Yeah. Okay. Sorry, I realized I was holding up the.
Oh, okay. Yeah. So like we can always show where the board is. We can show where the score is. We can show the line count. Um, I'm still trying to figure out if statistics is worth looking at. Um, I think that there's some like, oh, because of the number of line pieces that are there, like this could have been your like most like optimal score. But even then, I don't believe that. Like I have seen instances where you get like line pieced out at the beginning and you're like, there's nothing you can do with that other than just keep throwing them down. So like that's not necessarily helpful either. I think the level is important. Is this me playing? Because if it is, like this is no.
It's way better. This is level 18. This is way better than me. Like I don't think we should like at one point I'll show you how I play Tetris. And just be crying.
If this becomes a regular thing, I think that's definitely going to happen. Hey Patrick, hey Brittany, happy to see both of y'all. One of the you want to see Tetris strategies? I mean, this is it. This is why we're here. Don't point at me.
I am sorry. I think you know something about this.
I've been known to play a game of Tetris or 8,000. Like it's fine. But I don't know how long we'll be doing this. We'll be doing this until we're not doing this.
We'll just solve all of our problems in the next like 30 minutes, and then the project will be done. Clearly.
I mean, what's the plan for like? I think we want to like present something like this at like PyCon. Like, I think we got time.
I hope so.
But I think I think we can definitely say that. Let's just map out what we have. Oh, and then from there we can just roll with like, all right, check the line count, check the score, check the board. And I think those are kind of the most that we really need. Oh, and next piece, I guess, because next piece is an important bit of that too. I think the only other, so I guess to catch viewers up, the thing that we're trying to do with this that's different than some of the other bots out there that I've seen, which are like, I forgot what it's called, something Rabbit, Stack Rabbit, which is from a developer at Google. And then there's another one that I can't remember who made it, but we're trying to take it from the approach of like, I've been saying like tetramatic complexity because the original idea was the idea of cyclomatic complexity. If you want to know more about that, Anthony Shaw did a talk about that a few years ago at PyCon. And then that was also the impetus of Wiley. But like the idea of cyclomatic complexity is like how complex is your code? Like how many cycles does it have to navigate through in order to process a single bit of information? And you want that to be as, in a perfect, efficient world, as few as possible. And the reason I thought about this was with cyclomatic complexity, there's like this pyramid thing where like you want low hills in all of your stuff. And with this, you kind of have an ideal board state, and it's like a slight left downward slope. Like the peak is on the left-hand side, and it's as balanced, but also sloping in a downwards position. And there's a lot of hertz like strategies. It takes this many hertz, and also pieces rotate clockwise, so it's it's important to make sure that when you're turning it, it has to go like a certain way and like all this other stuff. But we know the rules. We know what a healthy board looks like. So create a baseline for what we would consider to be a healthy board, and then use that to create the base, and then use machine learning to assess when deviating from the base is considered good or bad. And there are a bunch of like Tetris strategies that can be deployed in which you intentionally deviate from that base so that there's a bigger payoff in the long run. And we will eventually get good at explaining that and turn it into a video of some sort, I guess, to make sense of that.
I'm trying
So
to find. You had a great page, or maybe it was Joseph who shared that, like, for the different techniques.
yeah, so with modern Tetris, there are a slew of techniques that you can try. A lot of those don't work in classic Tetris because of like the bottom is quote unquote sticky. So like once the piece touches any other piece, it stops. Whereas in classic Tetris, or not in classic Tetris, in modern Tetris, you can still rotate a piece, and that gives you the ability to move. And that's how things like that's why T spins are significantly easier in modern Tetris. Every type of spin is significantly easier in modern Tetris. Also, there
can do spins in classic Tetris.
Can you do spins? Yeah,
I
you can. It's hard.
Hmm.
Hey Ben, how's it going? I should even say it's hard. Once you figure out how to do it, it's easier. But it's not. It's. I don't think I would ever say it's easy. But I think with this, I think this scratch is good. Is this something that I should have been adding to like our GitHub issues / milestone thing?
I will. I actually have a window where I was working on kind of turning these into, well, for the overall project, I think there's 3 milestones for the MVP. One, digitizing the game board, game state, so we have data to train on. Then there's the training step, and then there's the actual having some sort of deployment, test environment, way that you can view the coach. Real time as you're playing, question mark. I'll start with a post process, like a play-by-play recap, something.
Well, we had talked about this idea of can we treat this almost like a game of chess and use that as a way of like chess has a very standard nomenclature that is hey.
Yeah, so I was adding some milestones here while you were spinning up.
So smart. So smart. Yeah. So like with chess, there's like a standard nomenclature of like this piece to this spot on the board. And since we know that like classic Tetris is, I always say 10 by 20, and I have no verification of that, but I'm pretty sure it's 10 by 20, or 20 high, 10 wide, with the same types of pieces. And you could then use that as almost a grid-like nature to say like, if step 1 is we just log every single piece and like how it was placed, I think that in itself gives us the ability to not only train on our data, but train on existing data, and then have a model of like saying, hey, following this line of pattern, this piece would normally go to this position on the Tetris board. And then from there, you can kind of work off of that, which also should speed up processing time, right? Because then you're not having to, process the data in terms of, I'm looking at an image, I have to conceptualize this image as some form of data and then return whatever the response in some form of data is. And then also then reconceptualize that to a board state. You can just say, I have text, and given a pattern of text, this is what I would have suggested.
Yeah, it's an interesting question. Like, digitizing the game state seems correct. However, there could be a path where like you literally are just feeding it the video data and like do deep learning where you just like let it go from the everything that's there on screen. But yeah, I think my brain maybe lost the thread, but I think something that would be, so we have the planning and pre-setup, digitize the game states, train the model, and then have some end user
feedback for
modes. Need a way for users to use the train model on either live or post-processing.
Oh, nothing. I was looking at this, but also thinking of like where my skills come in on this, because right now it's like data science. Jay, tell me about Tetris stuff.
No. I'm specifically on this last one. I think there is an interesting one way I was thinking about this. I watch a lot of games done quick and like speed running and stuff like that. And I've seen some cool things where there's like a game analysis tool for streaming where it's not necessarily like the latency is bad for the actual player, but like if you are the audience watching, you can see. So like I was wondering if it would be possible to do some sort of like web app or something like that where you could basically connect to some sort of data storage or maybe like an event hub or something like that that's sending images, or maybe maybe we have the game state digitization happening on the player's side. I mean, ideally what I would like is for there to be nothing happening client side.
Yeah.
But
so that is possible because that is how tournament classic Tetris is played right now, where there are you would think the Venn diagram of people who know how to code and people who like playing games from the 1980s on the original hardware. Yeah, there's a lot of overlap there. There's like this client that doesn't necessarily do what we're trying to do, but it does like read the game state. It knows when Tetrises are. It computes scores beyond what the game was programmed to do, which means that it's aware of a few things. And it also then produces that as a stream that people can view. The reason I'm saying, why don't we just use that? Or the reason I'm not saying that is like, again, I have no idea. Like there are requirements to do that. There's certain hardware requirements. There's certain like other stuff that you got to deal with that become kind of an issue there.
So is that JS?
No. This is called, what is it called? Max Out Club. It is not on the list of things, which now I got to figure out. I think it's like, I'm trying to figure out how it even does what it does. But from what I can tell, people like they connect to it through like OBS Ninja and then share their stream. And then it picks it up and then it provides the overlay. And then from there, the actual stream hosts just co-stream Max Out Club.
Interesting.
Yeah.
That would probably be a model that would be most helpful to the user.
Yeah.
But kind of cuts out most of the cloud part.
Yeah.
So,
yeah, and like I said, I don't think that I didn't even put it down as an option because again, we're at the time of the year where the World Championships are about to start. And yeah, I don't know who runs Max Out Club. I don't know who is like responsible for that or how it operates. You're like, oh.
I couldn't figure out how to rotate pieces, so I quit.
Yeah. So that was one of the reasons why I was like, let's just stick with Classic for now, because like JSRS and the other one, Tetrio, have different key commands, which then there is like that idea like, okay, you could just do input detection, which is kind of cool, but at the same time, if everybody has their preferred way of playing, or you have to then program for a few different options, that's not fun either.
So, question though, because I think that actually gets at an assumption here, which is, as I think you were kind of educating me about earlier, there's lots of fancy input methods to kind of get pieces where you want them the fastest, including using capacitive buildup on the buttons in the controller, which is way too advanced here. Yeah. Should the user input be part of the model apart from just how the piece moves? Like, there's definitely an interesting question there that could help optimize, because anytime you get like human behavior into an optimization loop, that is a good place for ML as opposed to like closed form, just like statistical models. But is that something we want here? Because that's going to be, as you say, kind of hard, and I don't even necessarily know how to capture that when we're just using like a streaming card capturing the NES.
Yeah. I've reached out to a couple of folks in the like developer Tetris community, and everyone kind of has their own way of doing it. I know prolific Tetris community / developer Fractal, like he has his own system that does like hertz detection, and he's also like a phenomenal Tetris player. So like he is actually doing input detection from his like NES controller, and how he's doing it, I have no idea. I think input detection eliminates the use of classic Tetris through just a stream card. And the reason being is that I do know of instances where, like, you know, you're sitting there playing or what, it's not plugged in. I promise I'm not playing. Like, you know, you're playing or whatever, and like you hit the button and like maybe it doesn't register, or you know, again, if you're doing something like rolling like that, you would wind up like that's the hardest part of people doing rolling, is that there's a pattern to it that is the natural like response rate of like the NES, that if you do it too fast, it doesn't recognize the input. So if you have, you know, an intermediate capture device that is detecting your input at, you know, 120 hertz, and your game is only moving at 60 hertz, and then you hit something that's somewhere in between and it gets detected by the input device but not the game, I think that becomes an opening for like issues and errors and things.
Yeah. I guess my position on this is keep it simple. I think
absolutely.
So I think we're on the same page, but I feel like, yeah, we really shouldn't in the initial scope, as someone whose middle name is Scope Creep. Like, I do this
thought
to
it was pie.
myself. Pie, Sarah Pie,
Sarah
Scope
Pie
Creep.
Scope Creep.
I should just put that in my Twitter username, like Sarah
Oh.
Pie Scope Creep. I'll do it after this.
That reminds me of that Drake song. It's like the classic like Forever like Drake song. It's like last name ever, first name greatest. It's like last name creep, like first name scope.
That would be like a great parody, like a Weird Al. Let's stick Weird Al on that.
Oh man.
But yeah, I say that I would suggest that we don't try and do that. That is definitely the fun part about this is, if we develop this kind of like data capture pipeline, once you have all of that available and, usable from blob storage or whatever, you can train on that really easy. So like, if there's data that's easy for us to capture, like the score or even the like stats of the pieces, I don't see why not. But if it's not easy, then no.
It's not easy. Don't do it.
But I mean, at least for that, like we're already going to be doing the text detection from a specific cropped region. So we just crop the individual regions for each piece. We don't even have to ID which piece. Like it doesn't seem like a lot of additional overhead.
So what are the individual identifications that are happening with each piece falling? Like can you rewind ever so slightly just to get to like the first position? Maybe not.
Yeah, I wish this I know VLC has like a go frame by frame, which is probably what I'm gonna do is try and open this with VLC.
Because I feel like that's kind of an easy indicator is if you're just looking in that spot for like a delta, like as soon as something pops up, you should be like, okay, we're on a new piece, new turn, let's go. And the only time that runs into a problem is if you're about to lose. And at that point you're like, well, I was about to lose anyway. So like not a big deal.
I don't know why opening VLC decided to run a print dialog. I think I have.
We work for Microsoft Cloud, not necessarily the Windows 11 team.
Okay, I guess I don't have it installed, so that is unfortunate. But we'll get it installed with Chip here.
I think that's fine. I'm trying to see. I'm trying to figure out where that cable ran off to, because I can at least do kind of a freeze-ish frame thing, but I don't know where I have like one cable that's for my HDMI to like RCA adapter that has apparently run off, and I will need to go locate it eventually. Is this it? No, that's not it. But
your question is like, what does it look like when it first comes on?
Yeah, because it will always start perfect. Yeah, it always starts in that position. It always starts there. So you're just really good at pausing. I like it. But if you have the board and you can just isolate that region, that 4-column or 6-column grid, do you want to do 8 columns because of line pieces? I think so.
I mean, yeah, I think for like what I would hope for each frame here, because like is that basically we would have the 10 by 20 grid here, and there's basically just zeros and ones, zeros where there are no minos and ones where there are, and there's basically a timestamp or like a frame number as you go along.
So it's like the NumPy array style.
Yeah, I think I'd go with X array just so that which is kind of
I don't know these things. I'm just gonna assume the array of things.
So as a quick TLDR, because I learned about this, I had been using them, I think with other packages but not realized. But like it is so cool because you can, like, you're using numpy arrays, but it's kind of a generalization that it allows you to have really ragged data, or like in this case, we would have like a board snapshot at a particular timestamp. We'd have a score. We would have on deck. We'd have like the on deck piece, the stats. So like we'd want all of that data to be associated with that time. And so like you know, kind of they give an example here of like you have latitude and longitude data points, and then you have precipitation over time and temperature over time, and it makes it super easy to index into that. So rather than having to like play a bunch of index gymnastics or dictionary, like it just makes it really nice to actually access that data. So it's a super cool project. It actually also works, as you can see here, in PyScript. Which kind of makes sense because nobody does. But anyway,
yeah,
it's a lot of the same core underpinnings, I think.
Okay.
But anyway, so the main reason I would suggest this is just so it makes it easier for us to index into kind of the game state over time.
Okay.
So that's a fun one for that.
If we're looking at it turn by turn, would it be able to? Because and this was kind of the reason where I was thinking of like doing like a chess style nomenclature, was the idea of available available spaces. Like, how do we? Okay, hold on. Before I even go down that rabbit hole, one thing at a time. Identifying the starting blocks, because I think that there's two ways that we can go about doing it. We could look at like a 1 2 2 2 2 no 1 2 2 2. There we go. 1 2 2 2 1 2 2 2 1 at the top. So I'm going to call them rows 0 and 1 because I don't know what they're actually called. But rows 0 and 1, starting from, and I really want to know if a line piece starts. Can you work your magic and find a line piece to see where it starts?
Where do I have a line piece on deck?
There it goes. It looks like it's coming from the. We'll see it the next piece. We'll see it in the next piece, Connor. It looks like it's starting on 1 2 3 4. It looks like it's starting in column 4. So if you just do like,
I'm pointing at my screen like you can see.
0 4 to like 0 4 1 4 to 0 7 1 7. And just have that area reserved for when there's no pieces in there, it's waiting for a new piece to determine that a new turn has started.
Would that be true if you're about to lose?
If you're about to lose, yeah, that's what I was saying, is like, how do you detect if you're about to lose? I mean, you could also look for a change in the next box. Wow. Look at that.
Quick, yeah, so that's drama right here.
That's 0 4 to 0 7. I could see either detecting in that space or just waiting for changes in the next box. I don't know which one is more advantageous.
I think it would be more robust to look at changes in the next box, just because I feel like it's going to be hard with potentially spicy games that you might have something else in that.
If it's that high, the game is over. Like,
I don't know.
At least for me, if I'm playing and the board is that high, the game is over.
Yeah. So I'm just gonna start slapping some assumptions in here. I'll put them in issues in just a second. But
I the one concern that I have about using the next box is I don't know frame by frame if it like how it's detected. And like if my assumption is correct, the piece appears, the next piece is calculated, and then the next piece is shown. And I mean, we're looking at it from the perspective of like, can we sacrifice that efficiency, losing that time and like detecting? Will we even lose that time in detecting? Or will it cause confusion in like frame, like looking at the frames? And that might even be a reason to look at the next box, is saying like, okay, we know when the next box changes, there's absolutely a new piece on the board. Well, ooh, that's the problem. Back-to-back pieces of the exact same kind, which do happen.
all right, we're gonna answer as
many questions as we can.
I can get VLC to open here, please.
If it starts printing again.
Wow, I clicked on some random link. Yeah, I think the chess thing. So I think that's. Yeah, there are pros and cons to kind of like having that description. I think that's probably more human understandable because that does at some level. Charlie says, "Can you associate each piece to a key?" I think that makes sense.
I'm trying to understand the context.
Yeah, I'm going to take a stab to see if I understand this here, but
okay.
So like as in this, yeah. So as a piece comes in, you would like you need those chess moves, but then that also implies some sort of registration on the initial Tetronimo and some sort of like do they always rotate about the same axis? So like the game state could have kind of like rather than just caring about literally what minos are filled, have a tag associated, like basically so you could have metadata about how you can move it as it comes down, right? Because the chess moves wouldn't, like that I think implicitly has associated with it what piece it is. Does that make any sense?
Hold on one second. Teams decided to do Teams things.
Just, do you not care, VLC? Do you hate me? That is an app. I would like you to launch it. Okay. Charlie says, so to avoid duplicate pieces, so as a piece is generated, you may want to associate a key with each generated Tetronimo. In that case, you can identify each individual piece.
Here, I'll bring this up on the screen.
Oh, nice.
Yeah.
So fancy.
I know, right? We'll throw StreamYard. Shout out to Charlie Devs.
Yeah.
Nice. Okay, so avoid duplicate pieces. As a piece is generated, you might want to associate a key with each generated Tetramino. That way, you can identify individual pieces no matter if they are the same.
Like if they're the same as in up next and what is currently on the field is the same?
Well, and this is why I was thinking, this is why I was earlier asking the question, does the piece count or the statistics need to be included? Because the simple answer there is whenever a new piece is dropped, the statistics are automatically updated. So you could use that as kind of the state indicator. Because what I'm thinking of is if this were like an object-oriented, just from the game side, not from the data like detection side. you would have a game object, a turn, and in that turn you would have like the board state, the statistics, your score, the current piece, the next piece, the level. And then I think there
So
would be a couple of methods there for like list of potential moves. So I think in that case, you're like, you just need to know when to end a turn and create a new one. And I think that's where I'm trying to figure out like what's the best way to do that. And I mean, again, the statistics changing, that's I mean, it's the one thing that's always going to be unique is if you do a total count of pieces dropped. I just don't
oh,
like
that's
the
an
idea.
interesting way to do that.
I just don't like the idea of you're now adding a calculation that has to be done before you identify like another like okay, hey, we're in a new turn, do something new. Like where are we looking and what are we collecting? Unless what we're doing is we're saying take a picture of the existing frame and then get all of the information each time. And then from there, use that to determine if you're in a new turn. And I think that way you can even collect frames and say, like, hey, in this turn, give me all the frames that are associated with this turn. Because I don't think that will help in like the data modeling side of it. But I think that could help if you're looking at like, I want to see a playback of this. Show me this one turn. And then now you have a collection of frames that could be turned into an animation.
Yes. So I think there's kind of two. Okay, let me back up and try to make my thoughts coherent. I think for the purposes of some of the models that I've been looking at and thinking about, all I care about is zeros and ones. I don't care when, like, as soon as the piece comes on the board, like, it's just represented by ones. I don't really care what kind of piece it is. That all is effectively like, push into the actual learning of the model.
Yeah.
Now, that works for the computer. And and I think what you're getting at here is a very important and interesting aspect, which is how do humans understand the game state, and how can like the recommendations or whatever sort of feedback we get from the model be translated, or even just modeling the actual data itself, be described in kind of a human readable fashion.
Yeah.
So I am wondering if that actually can't be derived. Like if we do the initial parsing with just zeros and ones, if those descriptions can't be parsed from there. Because as soon as like the frame, you'll have a matrix where the game state will have this key for the next piece, this all the stats and stuff like that. When you have a change in that parameter, that would indicate, we can come up with some metadata that indicates, hey, this is a new turn. And then I feel like you should be able to kind of rederive from the actual just binary representation a human readable representation. Does that make?
If I'm understanding, because it's in an array, that array could be. We don't have to worry about the game state as much as we can rebuild the game state from the array that we're given.
Yeah, I mean, like,
okay,
the most fundamental bytecode version of the game state is just looking at, a matrix representing the board and some other numbers, basically.
How is that going to work when the pieces are in motion? I just wonder because as the block is falling, you're going to have deltas throughout the array that are consistently changing, which is why I was wondering if, for a few reasons, one of them being like learning and resource consumption on learning. If you only want to collect the initial state and the end state, I know that there are a couple of like some techniques. I think that for minimum viable product, it's not necessarily a problem. That losing like T spins. This is like a good question of like, okay, we had talked about adding complexity to classic Tetris moves that are just harder due to refresh rate limitations. So like if now you're just saying, oh, all I care about is what's at the beginning and what's at the end, forget all the rest, you now have a problem with calculating T-spins because you're like, oh, hey, there's a place to do a T-spin, just do that. And it's like that's not necessarily that's kind of easier said than done in some cases. But I think that if all we're concerned about are the X arrays when there are pieces at the top or there are pieces at the bottom, I think that all of that like works. I just don't know how that's possible without making it like a turn based like idea.
I guess I don't know. I'm gonna try to be anti-scope creep here, in that, which is not the position I'm normally in. I don't care about optimizing for resource efficiency. So that's number one. Number two, again, yeah, like no, it's CO2 is high in here. Yeah, I think it's really what kind of we're thinking about that's different here is literally just how we're modeling the game state, right?
Yeah.
And I think there are, I don't know, I feel like it should be possible to go between them. And I think just for at least ingestion into the ML models, I'm going to have to turn it into the matrix.
Oh, no, absolutely.
So,
I agree with you on that. I think this is actually kind of a good like indicator of like almost like separation of responsibility in the project itself of like my role in this is how do I take data and make it presentable to the audience, be that the player or people watching. And then for you, it is how do I take raw data and make it fit a model?
I like that a lot.
And I think that works because we can then put it in the position of whatever that in between is, we can figure that out. Like if I do like, hey, here's everything that exists in a turn, then it's my responsibility then to say, all right, I can look and see when the X arrays are at this state and this state, this is now a turn. And that can be completely disregarded amongst the model itself. We don't have to look at it from like a perspective of turn 1, turn 2, turn 3. You just have to look at these are board states as they're happening, and this is how the model works as these board states are changing.
Yeah, so if I understand you correctly, you don't care about the game state while it's dropping, you just want to know kind of the initial piece, the actual game, the board state, and where the player ended up putting it.
Yeah, like if I were to, like I said, if I were to create a class, it would have all the base information about the game and its current state in that turn. What piece do I have? What piece is coming up next? What does my board look like at the beginning and what does it look like at the end? And then I would say there's probably a method in there that is like get all possible moves. That just makes this easier to say, like, okay, here's every valid place that I could put the board. I could put a piece. Because I mean that's like my one thing is like if you put it in a model, it's like, yeah, just put everything up in the top left corner. You're like, that's not a valid place for that piece to exist unless there's something there below it. But I think for that, and that's where like I think it would be beneficial to know about the X array as it exists of like, okay, hey, here's where it starts. This is what it looks like when it starts. Here are all of the places where you can put a piece, and then ultimately here's where you put it. And then use X-ray to create that quote unquote tetramatic complexity. And then say, oh, yeah, we want it to look like this. This is where it is. This is your overall complexity. And then machine learning says you did a good job or you didn't do a great job, or here's a better job that you could have done. Taking into account that there is no, like, this is void of that complexity calculation.
So I was just trying to write down the things that you were saying and maybe like what
The types
so maybe,
are
yes. So
board state.
Yeah, so that'd be like
Piece.
An array. What is the next piece? That's an enum. Score, level, stats. That would be a dict from the enums to ints.
Current piece.
Oh yeah.
Yeah.
I don't know. I think it's this.
Yeah.
Sure. I'm letting Copilot here just write all this.
I think with stats, I mean, we can simplify stats and just call it an integer because we're not trying to do any type of predictive like stuff. We're just saying like, hey, this is how many pieces you're in. Like, you can't have a Tetris 3 pieces in. It's not possible. Like they're like certain moves that you can't do because of where you are. And again, like we start looking at the transition marker based on starting level is probably also one to have. Because if you're starting at 0 up to level 10, no, up to level 12, the levels change at different intervals. So if you start at level 0, every 10 lines, you go up a level, and then the speed of the board increases. And then if you're at level 18, you go 130 lines, and then the board, that's when you go to 19, in which the drop rate increases. And maybe that's a thing to also calculate as well as drop rate. Like how many frames per second is the piece moving at?
So like current FPS or something, and then we have a method that calculates that based on
based on the current line count. Well, the current line count, the level, and the number of current line count, level. I think that's it. Yeah. Because that's where like I feel like both of these kind of fall on their head of like, oh yeah, just put this piece over here, and it's like, well, if the board is moving faster than I can throw that piece there, then that's not a valid placement.
And I think you talked about before current possible moves.
Yeah. And again, current possible moves is going to have, again, trying to avoid scope creep on this. Given the starting position, the starting array, the current FPS.
I'm cheating by putting self.
Yeah.
So it has access to everything.
I mean, yeah. So given the board state, the current FPS, and I think that's it. And the current piece. Yeah. This is all my stuff. You're doing my stuff. I mean, I appreciate it.
Well, no. I mean, I think this is helpful because, like, yeah, from my perspective, I think I'm just going to turn this into a matrix. There are possible, and this is why I think it's helpful, you know, if you do kind of make some sort of translation between moves and or descriptions that Tetris players will understand, and, you know, the computer view of the world, then we can take the output and basically run it through the converter backwards, or basically have the output be represented in sensible things.
Okay.
That makes sense.
Yeah.
So I think it is a useful kind of, I'm thinking of it as like an MLIR. So a representation that's still more human readable than bytecode, but but computers don't exactly want to work with it that way.
So I'm seeing something here. The stats in turn, I think those two things are the same, but identified differently. I don't think we need to know, because if I'm reading this correctly, the stats would be, as you're seeing it here, the number of each piece that's been dropped. If we were playing modern, that would matter because of the new Tetris algorithm that they do. I think it's called like the power of 7 or something like that. Tetris 7-piece algorithm or something like that. And basically what it's saying is you'll never, within 7 pieces, you'll never have the same piece 3 times, and you should have every piece fall within like a certain number of like minos, tetraminos.
Gotcha.
Let me see if there's a thing. Oh, Pierre Delacharles algorithm. Is this it? As El Tetris is an algorithm for playing Tetris by inspecting only one piece at a time as opposed to 2 or 3 pieces. No, never mind. This is not it. There are so many Tetris. Everyone loves Tetris.
So yeah, I think we could have, like, in terms of identifying, this was what I was thinking for having both the level and, like, I agree with you. You can derive one from the other, or sorry, the turn from the stats, or not vice versa. But you could have something that just basically watches, you know, on every frame update or whatever, or every board state update would look at the current piece and next piece. And if the current piece is now the next piece.
I just realized I tried to throw a link in there and it was like, yeah, you can't click this. So I'm sending it to you in Teams.
I gotcha.
Yeah, it talks about the randomization of it. I think most games now are history-based random. Where NES is unique. It's an odd system of randomization using binary math operations that are intended to produce truly random sequences, but result in statistical differences in the likelihood of particular blah blah blah, that whole thing. Yeah.
So that's it. I didn't realize that there was different randomization for the different game modes. That would be an interesting thing to kind of account for, or like track in some, like in a closed form sort of like solution, like as long as it doesn't change over the course of the game.
Once you define the piece order, like, or the piece randomization, then I think it's the same throughout the game. I know that some games, like I want to say J-Estris, you can actually change how pieces drop, like the randomization in which they drop. Like I said, for this, that's why I was saying ultimately I don't think that stats are that important in terms of knowing how many times each piece fell. I think you only look at and actually, is turn? I'm trying to think if turn is important.
Like in terms of like the binary representation, I don't care about turns. That's not like it's just a frame, and here's the next frame, and here's the next frame.
I don't think turn is important either. I would like individual turns because you could store them again to try to get that game replay. Like if I wanted to just replay a game as it happened, or I guess quasi as it happened. Well, I guess if you have all the frames, you could play it back as it happened. You would have like turns, which would just be an array of frames, and then again each of those states.
Yeah. I think something I want to do maybe for next time, maybe right now. I think I want to close up some threads and get stuff into issues here.
Yeah.
But maybe what I can do is I can make like a fake version of like what an X-array, like a individual frame game state would look like in X-array.
Yeah.
Because like, yeah, it works well with pandas and everything. So
this is where we're gonna get super nerdy, because I'm gonna say, is there a way that you can use like what is it, rich codecs to say like generate this X-array and turn it into an actual image, and then we can just put it into our documentation?
I don't see why not.
I mean
it's going to be an NP array if we can draw a matrix with cells filled or not. Like that's not a problem.
Yeah. I do think that'll be helpful, because I think that, like you said, this board state would be that array. Mm-hmm. Next piece would just be calculated off of whatever, either what's in view here. Current piece would be what's in view at the top. I'm moving my mouse as if people can see what I'm referring to. Stats we don't need. Turn we don't need. Turns would be great. And then
what's the 23 up here?
That's lines. That's the number of lines that have been cleared.
Oh.
Yeah.
Can you derive that from the score in reverse? Or?
Yes.
Okay.
Depending on the level, every number of lines cleared works on like a calculation. So one line,
linear algebra it out.
Yeah. Well, the only problem is it changes with each level. So then you have to know like what are the score values of each level. But yeah, you could totally look at the number of lines cleared and look at the score ish. Technically, if you push down, you get bonus points. I don't want to say insignificant, because someone will find this video and yell at me. But it's a single digit of points. So if you push down from the beginning to the end, I believe it's 9 points that you get. So you could calculate with some margin of error, like exactly how many like singles, doubles, triples, and Tetrises you got. In order to do that, you would have to I guess you could do that with just level though.
Yeah, like, so yeah, I think my next tasks are going to be something like this, where I cut out all those individual areas and try it. Like, I was just kind of flopping around in here looking at spectral distributions to try and figure out if there was one I could use to threshold for stuff. But that was when I thought I cared about color. You can also do fun edge detection. And I was trying it on some different screen caps. But what I will try and do is see if I can. I'll make a mock version, not automatically generated, of the X-array here. Let me make a to-do list here, which again I'll turn into an issue. And I want this as markdown cell. Thank you. So mock up an X-array to represent the game state. So that would be just a single frame. What does that turn into?
Okay.
So that primarily being focused on what I will need to like propagate to the rest of the training. That would also be something available, like once we parse the frame, whatever tooling you want to use to convert that to like a human understandable game state, or like be able to replay the game cleanly from the actual just game state, not the state data, not necessarily the actual screens.
Yeah.
And set up all the crops. So I assume like this one that you sent me, it should be the same every time in terms of physical positioning, right? Because it's just going straight to your capture card, right?
Oh yeah.
Okay, that's another thing. Capture card frame alignment is consistent.
Yeah, I'm sure. I don't remember if it picked up my audio or not, but I'm sure there was plenty of me complaining about the millisecond adjustment that you have to do when playing through a capture card versus playing direct to source. It does mess me up. It definitely does. Let me see. Oh no. What is this? Oh, yeah, I have no idea what happened to that cable now. That's like the next big thing on my list is I gotta find that cable. Oh wait, is this? No, it's not. Okay. Okay.
So I would want to define what areas I need to crop for the different info. So like basically then I can take a frame and turn it into like, I don't know, like I always default to dictionaries. Is that bad?
Yes.
Okay.
According to our colleague, yes.
So question then, if I'm doing this and I have, so like it would be parsed into arrays, like that's kind of what OpenCV does.
Mm-hmm.
That it's pixel by pixel value, I'll grayscale it, whatever. So it's an array of floats, and I have multiple of them that that represent different pieces. So I need some sort of way to identify them, and I don't want to just pack them into like a list and assume someone will know the ordering of how would you do that?
Dang it. See, this is where. So wait, you have
Like basically, imagine I'm just like
Yeah,
screenshotting different parts of the, like I crop out this part, and then I crop out, the score area, and so I will take each of those pieces and then pass it to the appropriate kind of like parsing function.
I mean, I'm kind of basic, but not named tuple seems fine.
Okay.
You're doing that, and it's going to be more performant than a dictionary.
Okay.
Technically, a class or a data class would be. But again, I'm only thinking about this. Yes, I'm over optimizing only because talking with Anthony yesterday.
Yeah, we're gonna get in trouble.
I have a new repo that I started called Python optimization content or something like that. And it is literally using Perflint and all the Pylint rules that are identified in Perflint as like my next section of TikToks to do of like, hey, are you writing Python code like this? Maybe you should write it this way because, and then Anthony chimes in with the actual numbers like, oh, this can be this much faster.
That's going to be great TikToks. Maybe when you're done with those, I could try and sketch note some of those. That would be fun.
Oh, that would be awesome.
Like this is what Nitya, being kind of my onboarding person, she has been.
Yeah, that's been the goal, is like everything that I do, I want to do in like 1 to 2 minute chunks so that I can send that information over and be like, hey, can you do like a drawing for this so we can throw it up on Twitter? Yeah. Okay, so you've got those. And then I just need, if you can give me an example of what the X array will look like, even if it's just made up, like.
Yeah, that's the first one.
Yeah.
I will get you that, and then you can start working on.
I'm gonna take your games. Send me a copy of your game state class too, or I guess if you just throw all of this in like the milestone or something.
Yeah. So I was gonna. What was I gonna do here? There is a.
It might have been in standardized on nomenclature, but I have no idea.
So what we're gonna do is, let's say, I'm game.
Define description. I think the word there is describe. I could tell because it was like define description of it. I was like, yeah. And I can see your will, like the smoke is starting to come off.
Well, so I was working on that Discord bot yesterday, and I spelled wrong, because I spell a lot of things wrong. It was like cleared, because it was like something that cleared all of the events off your Discord schedule thing, but I spelled it wrong, and someone on the Discord I was testing on was like, I wondered if this was, you had added an off-the-shelf bot, and then I saw that, and I realized, nope, you were doing
all you need. Oh, this is cool as this. Where did you find this from? Oh, this is from your head.
There's so many squigglies. How can I tell them apart? As long as they're not red, I don't care.
Yeah.
Game state. Actually, I'm going to say game state model. And then I'm going to just put this and say like tutor. See, now
I wasn't going to say anything. While you're doing this, I'm looking for a cable.
Let's see, but I want this to be level 2. This really shouldn't matter. Models 2 ways. Like a menu.
It's just too funny because it's like typing, and then like, all right, Jay, what are you gonna do? I'm gonna make a data class. You call it a day.
X-array.
Make an array of X-arrays.
No, I just spelled it A-R-A-R-A.
Array.
There we go. This is very awful pseudocode, but okay. So there we go. That issue, it's number 13. We'll work on that. I'm also going to make an issue here for our assumptions. The problem is if I say the word funny, then I spell it funny. But if I don't say it, then I definitely spell it wrong. So I'm kind of doomed.
How does that work? I was like, wait, so you either spell it wrong or you spell it wrong.
Yep, that is correct.
Not in there. The moment your cables go missing, and it's like, normally you have a plethora of cables, but you need the one. And of course it's like a USB like micro. At first I was like, wait, will my like 3DS adapter work? No, it won't. Because ports. Those are a thing that we should care about, right? Oh, random USB cable, where did you go?
Fixtures.
Nope. You're a Stream Deck. You plugged in there. You plugged in there. Huh. This is where I then go to like Best Buy and find all their old unused cables. I'll be right back. Hold on.
GG. We don't have to ID pieces in each region. We don't have to. Just copy those. Yeah, okay, so then we'll know these. Assuming we know these things. Okay, so there we go. We've got assumptions describing the game state model. We need to parse things. Yes, so I would actually like to look at X-array here real quick. And
oh, really? Really, coffee? When we realized that it was the coffee machine this whole time, or it was like sitting in my coffee, like next to my coffee pot for some reason.
that would be an interesting way to extract information.
Coffee script. That's the.
I guess.
Like if we have to.
Nope. I'll find a Python to coffee script.
Oh no! Hold on, I want to see if it worked now. This is gonna be the. Uh-oh. Nope, It didn't work. Whatever it did. No, it won't let me share it as that device. It'll only let me share it as. That's weird. Wait a minute. What? Because it's there. I have no idea. I have no idea why it's not showing it anymore. Lame. Okay. Well, oh well. Actually, I could do this. I'm not a fan of. Actually, I think OBS already has it set up. Yes. So I don't know why StreamYard won't let me do it, but I have no idea how good the playthrough will be, though. If I do... Where did that camera go? Hold on. Just unplug it and plug it back in. Does that change it? Probably not until I refresh the... Oh, wait. Actually, yes, you're in here. Hold on. I can do this. I'll be right back.
Okay, so now I can put milestones. I can say... Okay, so all of these are effectively questions. I can remove the label. Okay. Issues, milestones. Here's what we need to do.
Hey, it worked.
Nice.
The only thing, I could probably do input. I have no idea how loud it would be, so I'm not going to hurt everyone's ears instantly. But I should. Oh wow, this is even harder because it's this little screen. Hold on, I can't. Hi everyone. I can't see.
So what's A type versus B type?
Yeah. Don't worry about B type that much. That was a bad idea. I shouldn't have done that. I immediately regret these decisions. There we go. I need to clean this up.
I'm just adding issues to milestones and PMing here for a minute.
This is research, so you can actually see the different board states.
No, makes sense to me. Oh, nice. Oh, it does the fun little flashy. I don't think I've ever actually seen classic Tetris.
Oh, it's the best. It's like the best feeling of Tetris because it feels so like it definitely feels like a relic, but it feels like I'm owning this relic right now. Except for I'm not, because I need to clear that well. There we go.
Let's see. Okay, so I am...
By the way, this gives you an idea of how. Oh, yeah, that's game. that's it. Yeah, that's it.
Oh, because it's sped up. I gotcha.
Well, it doesn't speed up, but it's the same. It's the same pattern, but it's moving at the same rate. But there's less pieces, and that's why I was saying that it's important for the model to understand that you can't. It can't make a suggestion that is not, we'll say, physically possible given like DAS standards. Because it would be like, yeah, no, just vault that thing over, and you're like, that ain't happening. I think there was also the
Correct.
question of, do we actually test this at level 0 or do we test it at level 18?
I mean, I won't be playing at this level. This is already about as fast as I get the Tetris. What is it? Unlimited? No. Effects. Tetris effects.
Tetris Effect, yeah. Oh, you're asking about B type? We
Mhm.
can't play. We can't do B type. B type is like, there's a lot of things. Your goal is to, like, I'm gonna do like 15-4.
Ah!
Yeah, exactly.
Ah!
And then your goal is to, I think it's to clear a certain number of lines.
I see.
Yeah, I don't play B type. Some people like
No.
warm up on B type because they're like, if I can, they do like 18-5 and all that other stuff, and you're just like, oh yeah, let me just yeet all these pieces all over the place. And I'm just like, nah. Level 19, I mean, I can survive for a few seconds.
Let's see.
Yeah, no, this didn't go well. Is there a way to?
So I will admit something silly here, which is so I think the first time I had even like heard the Tetris music was someone in undergrad shared like some YouTube video that's like words to the song.
Which Tetris music are we talking
Uh,
about?
dun, 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 dun,
So
dun,
the so
dun, dun,
the
dun, dun.
the non-classic classic Tetris music, because that music's not in this game.
Oh, interesting.
It
Okay.
plays, I forgot what it's called. It's the something waltz, I think. But it's dun 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 dun. Yeah.
Isn't that just also from the Nutcracker?
I mean, yeah.
Okay.
Hold on. Let me see if I can. I'm gonna set the volume really low because I don't know how loud it'll be or won't be. So I'm going to, where can
It's not too loud. Oh, that's such happy sounds, though. Some quality chip tunes right there. What's your preferred track? I'm guessing you're switching your mic back.
I forgot that you can't hear me as I'm talking with all the music things happening.
Yes. I'm guessing you seem to play with one?
No, I play with off. um, I play no music, and then I realized I was like explaining all of this, and I'm like, oh yeah, wait, you can't hear me because I have it routed through my camera. But yeah, I play either off or I play music 3, but I
Hmm.
prefer off. Just because there's, so you're talking about that like capacitive charge or
Mm-hmm.
DAS. There's a indicator of knowing of like that you either did or didn't get DAS. Like you can't hear it audibly, but like if you hear the like the clunk of the piece touching the next piece before you've started moving, that tells you that you didn't charge DAS.
Hmm.
So it gets kind of muddy when you have music involved. You
Gotcha.
can't see my face right now, but I'm like, this is like the toughest thing to do because like it's in this little bitty box next to your face.
Babby Tetris.
And I also have to play with like this minor delay, which is like, it's a thing. I don't think it'll bother most people, but I do agree that like in terms of training, probably on like, see, that's the problem is all the training data would be on level 18. If you're going to use like data that's out there, it'll either be level 18, level 19, or level 29. Because people just don't play. Some people play on 15. I think 15 is probably the lowest we could go while still having actual data to train on other than like me fumbling around because I'm not like the optimal example as this game is proving at the moment.
So I was also just one of the other things we need to like. I think there are a number of different tasks or like ML activities we can do with this data, which it could be that some combination of these goes into a coach, or possibly once we've spent more time on it, I can figure out how to do that directly. But very straightforward things that I see that I could probably do quite quickly. So the task of regression. So given a game state, predict the final game score.
Huh.
So it's a parameter that we track, and basically it would learn, if you're in this game state, that usually goes to a good place or that usually goes to a bad place very quickly.
There are like pace calculations that you can
Mm-hmm.
do. That would have to calculate the number of Tetrises that you get. Like usually a like tournament level game would be oh, this is going south. Okay, I'm gonna stop that now. uh Hold on, let me adjust the camera back to my face uh so that we are not just watching me flail about in classic Tetris. uh there we go, I'm back. um there's like, if you're playing perfect, you should get about 100,000 points every 20 lines. Again, if you're playing perfect, um, which then you have like max out pace. Max out pace is about 500k at 130 lines. It's actually probably a little bit higher. You can obviously max out if you can play long enough at any amount of points, but and a max out just refers to once you've reached 9999 like 69 or 999,999. But like I think I wonder because score, like if you're trying to say like, okay, as a coach, I like right now my personal goal is to get to where I can get 200,000 plus points a game. Like just on average 200,000 plus. There's a way of calculating in order to get 200,000 points, we'll say in 130 lines, you need to get this many Tetrises, this many doubles. Like there's a way to do that, and it's like just math. Um, I don't know what that calculation is, but I I think that there's going to be added value to just doing like as a coach your score improvement over time and things like that. And that's where I wanted to bring Anthony in, because one of the things I like about Wiley is Wiley uses Git to calculate your complexity over time. So as you, oh, I can bring this back up if you want
Yes.
me to.
Yes, I was just kind of. I felt like this would be helpful as we're talking.
Yeah. Um, But yeah, uh, Wiley will give you a chart that shows like your progression over time. And I think that if we're looking at like score lines and then using that to do some rough calculation of like you got about this many Tetrises, instead of using the screen flicker as an indicator, because there isn't a way to count how many Tetrises you have other than like calculating your total score versus your line count. But I think that it would be nice to say like you average this many Tetrises per game, or you and like in order to get your score up overall, the goal is just average more Tetrises per game. But you could say you also average a Tetris every certain number of lines, which like I think that could be used as a way to indicate like, oh, right now it takes you, 20 pieces to get a Tetris, or it takes you, 10 lines to set up for a Tetris. We need to get you doing that in like 15, and then we need to get you doing that to 10 to where now all you're doing is getting Tetrises. And that's not common. Most even professionals like often they will sacrifice a line to get a Tetris. But the goal is you either want singles or you want Tetrises. You don't want to sacrifice lines and doubles and triples. Because even though they're worth more points, they go towards your line count, which progresses the game faster.
Okay. Now that's interesting.
Yeah. And the
Um,
overall calculation, it's 760 points for a single and other numbers for everything else. And then like a Tetris is, hold on. See, level 18 scoring Tetris. Where is NES? Original Nintendo scoring system. Okay. Oh, this is an interesting. I'll send this to you in Teams as well. Uh, as I give you the math.
nice.
Uh, it's after level 9. It's 40 times n plus 1 for one line, and then 100, 300, and 1200. So that's where you're looking at kind of the complexity in terms of the score of it's like, oh hey, at level 18 it's 1200 times 19 for a single Tetris versus 706 points for, or 760 for a single.
Yeah. I'm wondering if, like, once we have a matrix, like basically a sequence of matrices, you should be able to tell from one to the other if a whole row disappeared or a Tetris disappeared, right?
Yeah, yeah, you would
So,
see a 4 by 10 column or 4 by 10 segment flip.
mhm. Well, just isn't it an
Oh
instantaneous
wait, no,
drop?
it wouldn't flip. Oh wow. Oh
It
yeah.
would
Oh, that
it
would
would just
be,
disappear. So
yeah.
I
So
think we
you're
could be able to. So, like, what I'm thinking is to help identify some of these events that are more like meta level, um, or in this case, actually just score related. Have something that just kind of scans through the frames and has a comparison, just compares the two matrices, looks at the difference. If the difference has a 4 by 10 block in it, then like whatever matrix operations are needed to determine that. Then we add a counter to the game state that's like you got a Tetris or whatever,
yeah.
and then you should actually be programmatically able to calculate the score, and you wouldn't necessarily have to parse it, but
Yeah.
it would
I
be
think
helpful.
the challenge with that would be calculating. Hmm. That's. I think the only one you can do that with is a Tetris, because of how the board. Because if with every piece being four pieces, the only way that you would have such a clean diff would be if all the pieces, if a certain segment of the board shifted down four rows.
Mhm.
But with singles, doubles, and triples, there's going to be added piece stuff from the piece that you just dropped. So I think really the only way that I think you can calculate it like with actual certainty is looking for the score to change.
Okay, that probably also works.
Or just counting, or whenever the line count changes. Oh, hey, the line count went from 1 to 5. There was a Tetris there.
Oh, okay, yeah, we're gonna go with that. That is what we're going to do. We're just going to
Yeah,
okay.
I
Um,
see a use for the match, the match case operation to happen there. Like, oh,
mhm.
hey, check line count. If the difference in total lines now from before is 1, 2, 3, or 4, then add these points or look at the score.
I'm just going to add this as an assumption. Uh,
The lines will
Tracking.
change in increments of 1, 2, 3, or 4. There's so many things that you're just it's like this is why I love this kind of project though, because most people are just like, oh yeah, you either build a game of Tetris using something like, Beware or something like that, and then you train a model to just play it, or you and then like that's your whole like machine learning thing is like, oh, I did all of this capture and had it watch and then had it repeat basically its own inputs on this game board. Or you have all of these things where you're like, okay, line count, like how is that important to this? All these things, how are they important? And those are I think the scientific term is weebly, like weebly wobbly. Like, so I love that there are some assumptions, but it's also like, assumptions, but also we got to think about how this affects things. You're muted, by the way.
Okay. Uh, is that Tetris's? Is it an ES?
Yeah.
Tetrisai? Is it Tetrisai? I feel like
I hear
that's cooler.
Tetrises all the time. That's what
Okay.
I would assume.
Okay, so I'm trying to like kind of identify what things I should target here, and I think what would be really helpful is I think a lot of the I tried to capture some of the things that you were talking about there, but like what things would you love to know from a coach? And then trying to reverse engineer from those things you want to know, because I think it is kind of unlikely that unless I use deep learning, that those answers would come directly out of the model, but it would
Yeah.
probably be something else that then I can use to calculate what the information is that you want to know.
Yeah.
Um,
In terms of coach mode, the to me the biggest thing, and I think I talked about it in like the playback video that I had sent of like
mhm.
there are times when like setting up a VITS vertical eyepiece tuck um or vertical eyepiece tuck situation, and or like setting up for a T spin, or setting up you know, when you have seven different places you can place that piece, and ultimately they don't really change quote unquote complexity all that much, but they prepare you better for future situations. I think that's like the big like machine learning. We had to watch a bunch of games and see what future outcomes were to figure out where you should put this piece amongst all of these places that are going to have, you know, in a base 10 system a less than one, weight difference between them.
Yeah, and I think that matches well with kind of the task format, whatever, of a classification problem. So that would basically require that the training data that we have basically indicate
I can
for
actually show you what
each.
this looks like.
Ooh.
Oh, nope, that's level 8. I cannot show you what that looks like on level 8 because one will be here all day, waiting for pieces to drop. Okay, so like right now, I can't necessarily like pause it and have you view what's happening, but there's an L piece that I'm going to just let fall right down the middle that could have gone anywhere on the board. What is the most optimal place to put that L piece? I'm going to put it not there or there. Same thing with this. I like quickly saw 1, 2, 3 different pieces, like places to put them. What is the best place to put it? Because ultimately, like for this, I'm going to put it there so I can put that there and put that there and put that there and continue to mess up because I'm on a little tiny screen. But that like there was that little like long area there that I had covered up that I could have sandwiched that long bar in. That's called a VITS. Like setting those things up, you're often doing them in preparation for a thing that's going to happen in the future. But without being able, like, where'd you go? You disappeared.
Yeah,
It's
thank
like,
you. I tried to stop sharing and accidentally clicked on the big red X of for Leave Studio because that looked like the stop sharing screen. So I'm sorry.
yeah.
I did hear what you said though.
But yeah, like adding, like setting the, wait, you did hear what I said?
I think mostly yeah.
Okay,
So
cool.
getting the setups, like, should you in this scenario be setting up for this particular technique?
Yeah.
Uh,
And there are
mhm.
a lot of those situations that come into account of like don't set up a VITS if you're about to transition from level 18 to level 19. Don't set up a VITS if you're not like on the bottom 2 or 3 rows. Just because remember, as pieces go up, the amount of time that you have to put pieces down decreases as well. So like when you're looking at it from that perspective, you have to then figure out like, okay, with this knowledge in mind, where do I put this? Like where do I put the thing to still be quote unquote optimal or suboptimal at least?
Yeah. So optimality here would be the strategy which most positively impacts your final score.
Yes. But I feel like final score is hard because of eventual like uh did Camlink give up? Did like cable give up? Did something gave up? Oh, okay. There we go. So like let me get onto this. So like here, if I'm setting this stuff up, that could go anywhere, that could go anywhere. My goal should be set up for a Tetris
Mm-hmm.
at all cost, which is like, come on, come. Okay, well, yeah, this is my life, and then I get 0 points. I'm bad. Little screen, very hard to play on. But like, so like at the beginning, it's like set up for a Tetris, and then when you fill when I do that thing that I just did of like, oh hey, I played some pieces. Oh look, I now have a hole here. I shouldn't be adding weight to that hole. Clearing that hole should be the most important thing because I can't get back to what is the optimal strategy until that hole is cleared. But as I'm doing that, I'm now creating more holes that I then have to think about. And that's why like getting clean or playing clean is like the hardest thing to do. And that's when like even though in most cases you want to play for either singles to set up for a Tetris or a Tetris, that's when playing for a triple or playing for a double is important, because you still want to get some level of efficient scoring as you're cleaning it up, and you want to clean it up as fast as possible until you're playing clean again, like this.
Interesting.
So like those different and I don't know if that's a thing that, like, I mean, yeah, like you said, overall score probably a thing that you play for, but I don't think that there's no like overall complexity thing that you can do. There's no calculation of like, oh, you have a hole in your stack. We're going to switch to this calculation of like how many pieces to clear the stack, even though that is a thing that would be beneficial of like, hey, it took you this many pieces to clear the stack.
So here would be another question and or point that I think would be really helpful if you could, because yeah, like I think I understand what you're saying. I'm having a hard time trying to figure out how to derive that or like identify that. Yeah. So if there was a way, like, because you've mentioned now like a lot of different strategies or rules or things like that, those are all closed form, right? So like you could have something that just watches the level or whatever and would just say, all right, you're going from 18 to 19, don't set this up. But what you, as you've been talking about with the complexity, what you kind of like then, or another optimization strategy that it could help with is, given this complexity, should you be trying this strategy to reduce the complexity? Is that kind of...
I mean, I think so, but like you said, I think that there may be a way to even do that in closed loop of like, if your X array has a clear hole in it, then your goal should be to fix that. But then now, like, the model needs to be calculating on the best way to fix it. And then also, if there were any coach, coach mode or ability there, it would be like, you could have cleared this in 7 pieces, but it took you 40. And here was why. This was the moment in which, if you would have put this piece here instead of here, it would have cleared the board for you, or it would have cleared up that issue that you had.
Yeah. That interestingly, I feel like sounds like a fun task for a genetic algorithm. Yeah. Anyway, to the actionable item here, which is, so the issue I was working on there for like, what things would you like? So imagine, and maybe the right thing here to do is like to literally mock up in Figma or something what a good coach display, like, or what a helpful coach display would look like. And then we can, yeah, like I'm just trying to pin down like what is the exact problem, or what is an exact problem statement that we want to address, and then it's much easier. And obviously I think there are multiple here, but then we can try and figure out what is the optimal tool to address that, because I do think some of the stuff that you've been talking about here with complexity probably can be handled outside of ML. Once we have this data, there's plenty of ML thing, like I would like to try that regression anyway, to just say, because like you can then track, kind of like Anthony has, you can track over time. You can watch your probability, watch the predicted final score go up or down. And that does take into account, like you could say, oh, it's a probability distribution or something based on the sampling for the next piece. This would capture kind of some of the things you were talking about, like in this situation, the optimal place for this piece is here, but humans aren't going to be able to get it there. So, like, that would be captured as a part of that kind of prediction. The other two that the other one that I think is pretty straightforward is classification. So that would be if we could take a game state or perhaps a short sequence of and identify what, I think one of the simplest ones is are they doing a center well, a side well, whatever. And basically have that as a label associated with each game state game state frame. And then that's great because then I can say, all right, here's what strategy they were pursuing, here's where it changed, and then the model would be able to, given a game state, tell you which of those strategies you should be pursuing based on the end success of the game.
That's interesting because there are well-based strategies of like, one, left well always bad, never do left well intentionally. I mean, you can, but it's suboptimal due to the way the game is programmed. Center well was a strategy for a while. There are people that still do center well. Center well is very high risk, high reward, but center well is great when you are at the top of your scoring or at your piece speed threshold, because then
you don't have to move
piece,
as far.
Exactly. With the line piece, it's literally you hit A or B and then it just falls into place, or you move it over one and you're there. Like, so if you're playing at a different level based on your personal score threshold, I can see where it would be valuable to say, hey, you're at 120 lines. You don't play at level 19. You need to set up for center well. That way you're going to top out soon. You're going to reach the end, a closer version to your high score. Let's try to squeeze out another Tetris. Hopefully we'll get lucky or whatever. And I mean, obviously I don't think that's what the return state would say, but if it's like user's score is this, user's average high score is this, center well probably the best idea at this number of lines. It normally takes this long to even develop center well, this number of lines to develop it center well. So maybe now is when you start moving over to a center well strategy to give you a chance of beating your high score. And I think the thing that's interesting with that is it goes against the idea of this is how you play the optimal game of Tetris versus this is how you play your optimal game of Tetris. This is how you play Tetris at the best of your ability. And I think that as that works, I just don't know how the model itself would train on that without being able to play the game itself.
So I totally agree with the statement, like, I want to train something that helps a human play the best game they can, not necessarily the optimal game, because optimal games, that's a closed form, easy, like you can work that out at any possible game state. Like you can work out the optimal move, but in particular when you have fallible humans in this loop making choices, that is, I think, that is an interesting machine learning question of basically trying to understand what can the person do given these situations. How did they respond before? Did that turn out good or bad for them? And then try to make suggestions based on, if the goal is maximizing or like beating your high score. Being able to make suggestions like that. But the critical requirement then for something like that is to have labeled data. So there's all kinds of different types of data that you can use for machine learning. You can have unstructured data, which is like just a bunch of random pictures, nothing identified about them, maybe they're all vaguely, maybe you're going to do deep learning with that or something, which is basically don't give the model any structure or instructions, give it something to optimize and hope it comes out in the end. Those can be some of the most interesting and powerful techniques because there might be things or parts of the model that we as humans don't think are relevant, but the model finds. I think for our purposes here, we're going to have a lot, like we have structured data. So we have these other attributes like score, like the game board state is kind of the primary piece, but we know these other things about it. It's labeled with these other things. And so we can do techniques that use labeled data like the categorization or like strategy prediction would be how I put that. The other one that I think, just kind of looking through our options, given the type of data we have, anomaly detection. So I think that's kind of interestingly related to some of the coaching things that you had mentioned earlier of this is where it went wrong. So being able to, given a game state, or rather, like upon receiving a new game state, say, hey, I think this was outside of your normal good play. Like, warning, this may not go well.
Right.
You have fucked up here.
I think that the hardest part in Tetris is the idea of I need to close the well. Like, you're not always going to be Tetris ready. Your goal is to be Tetris ready as much as possible, but you're not always going to be Tetris ready. So what you have to do is you have to be okay with I'm going to intentionally make myself not Tetris ready so that I can be Tetris ready when the long bar comes. Because whether or not you're Tetris ready when there's not a long bar means nothing. Like, you're at that point, you're like, where do I yeet this piece to get it out of my way to be prepared for the next long bar? Sometimes you have to make the move that flips a bit, that says, Tetris readiness. Maybe that's an attribute.
Actually, I really like that because that's pretty straightforward to find.
Yeah, like, is there a single piece of openness of like 4 lines that you can get to? And then from there, it's like, okay, again, that's okay to do when you fill up a Tetris that's resting on 0 or resting at the base of the board, not near the top. You don't want to close off your Tetris there because that might be the end of the game.
Yeah. Yeah, that's actually an interesting one. I kind of really I'd like to maybe explore that and see, because that's a pretty easy label to associate. Mm-hmm. Is this current board Tetris ready or not? Yeah. And based on your game, always here I'm thinking about for the player, not the optimal, not the optimal solution. The model knows you. It knows how you've played.
The model knows enough about you to know that you're not going to make the best move all the time.
Yeah, and so like knowing what, how you've played in similar situations, maybe the right suggestion is, maybe you would close it off here, but then because that pushes you to the next level or something like that, things speed up and then things go bad from there. Yeah. Maybe, so like basically a flag it can hold up that says, as you're playing, be getting Tetris ready. Don't worry about it. Just close some stuff off. All right, work on Tetris. Close it off.
It's like red light, yellow light, green light. Like green light, Tetris ready. Yellow light. All right, it's fine. Fix it. Red light, fix it. Fix it. Fix it now. Like... This is our Azure Functions IoT new thing. I have.
Yeah, we just make a little Arduino thing. Adafruit has a stoplight thing.
Oh,
Did you buy that?
No, I didn't buy that, but I do have. I have I think it's called like a Pi display. But it's basically just a DigiKey that like you could just set it up and just have it like reading. Actually, I have that, but I also have this. Oh wait, camera. So it's just like a little hex grid. So like we have the ability to introduce like there could be like a happy like the coach is happy and like the coach is not so happy. The coach is very concerned for your board state.
I'm trying to find. Oh, here was a fun one. I don't want it on some other dumb site. Can you just give it to me on Adafruit? Poop you. Whatever. Just go directly to Adafruit. But yeah, they have like a little, like I'd imagine it would fit on like a train model thing. And they also have a bigger one that looks like kind of like warning klaxons, but it has red, green, and yellow.
Yeah, I love the idea of a very simple like, hey, you're doing good. Oh hey, yeah, about that. But I think that's where you're talking about using something like Figma to design, hey, this is what a board looks like. This is a good bad so board. I think that I think in terms of the coach, that's the way to do it. Is like I think you can't necessarily and maybe there's like spectator coach and there's like actually help the player coach.
There's like a commentator versus a coach, right?
Yeah, because you're not going to be able to have a visual representation like happening as you're trying to play the game because that's just a lot. Like that's a lot going on. But you could have some IoT solution that is an arrow pointing to the right for like, hey, or like a check mark saying like, hey, you're Tetris ready, or fix the line. There's like a caution, like it's you covered it, but it's fine. You covered it, it's not fine. Panic, 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 panic. Oh no, Mr. Miyagi's very, very upset. Like it's like there are easy ways to do that on a display, but I think you can provide a more verbose description of what's happening in like to spectators, or even a follow-up. Maybe that's what you call it, like replay mode, where like if the coach is in replay mode, it's like, all right, we're going through this game again and I'm going to show you all of the information, versus you're playing the game right now. I can't show you all the information. I can only give you, small gestures and lights to signify things are good, bad, or so.
No, I actually really like that idea. I sent you a link on Teams to the Adafruit thing I was thinking of.
Oh, it's like $20.
I know, right?
That is awesome. Oh, those are so cool. How big is it?
I think if you scroll down, it's in the preview video.
Oh, wow.
I'd say it's probably about a foot tall, or
significantly
8 inches.
I saw the cables and just assumed, oh, this thing is tiny. Oh, I see a quarter. Yeah, in relation to a quarter, yeah, it's like a foot. I'll throw it in the chat for the few people that have been hanging out with us for the last 2.5 hours.
Yeah, so I kind of because like part of this is I'm trying to figure out I want to have some part of the solution on the cloud. So I like there being kind of two.
I think IoT Hub like solves that.
Yeah. So actually, they could be part of the same pipeline. We'd have to figure out what the latency is if we did that. But worst case, we can have a local loop running on the player's side that drives. We train in the cloud and deploy models directly to the IoT device, and then the IoT device has access to your video stream or something like that, and then that loop just happens locally. So then we'd get to have some fun, like deploy a model, do like OTA updates to the coach. But I think, yeah, for me, what I would like to do with the different different ML tasks is I'd love to have like a commentator or a post game like analysis sort of thing that it could be while the game is still going on, but it's obviously going to be with some latency. Yeah. But basically have a web app that can take the game states, show the board, and show like, maybe like a graph of what is the likely end, for just like the first task. Over time, show kind of what the graph of the likely final score is based on this particular player's skill and the model trained on their previous play. Yeah. There are other questions. I'm like, wow, would this work for anyone but Jay? Yes, possibly. So there could be different ways to collect data and train on it. We could do it by like people who identify as like pro-ish. We could do it based on beginner, like if we were to do this at say a conference booth, we could be training, we could be collecting all of the we could do it off a averaged person's gameplay. Yeah. It can be a personalized
enter your skill level into this iPad here. It's like 3 big blocks of like, I know what I'm doing versus I have never played Tetris before. And then from there, I think that makes it a little bit easier because we can even use the Tetris, like tournament style Tetris kind of levels there, because you have, obviously there's like level 0. We're just going to assume that if you have like, I've never played Tetris before, or I've never thought about Tetris, I'm not that great at it, or whatever, you start at level 0, like, oh, I'm not too bad. You can start at 15, and actually, hold on, have to switching into Tetris mode.
Should make that a Stream Deck button.
Oh yeah, if I wish I could. I have to change the input in the camera, and it's all in StreamYard. So, so yeah, so like I have never played Tetris before. Oh, this is painful. Okay, we're gonna do a bunch of drop down. Like this is, I've never played Tetris before, and you're just like, I'm just chucking pieces, and they are moving with the pace of whatever.
This is honestly, this looks like pro Sarah play right there.
And then you have, maybe I've played Tetris before, and you play at level 15, which is, it's fast, but you got time. Like you can, I think the first, and this is actually a good kind of example because this is fast enough to like, if my wife plays at 15, the first couple of games, it kind of like takes her off guard for a second. But then like she plays a few games and she's like, oh, okay, yeah, no, this isn't bad. Like I'm starting to think about like how I would do this. So this is like a good speed, and this is a speed that people could within a game or two see some improvement on. Mm-hmm. So I think it's kind of like a good candidate of like, hey, we use this as a way to show people like you can play better using our Tetris Coach. And we're going to put you at level 15, which is, it is competitive. This is what, like, if you play at, I don't want to say like the semi-pro level, but this is usually what folks who might be like retired or a little bit older, the like hand-eye coordination and stuff is starting to drop. They often play at 15. And then from there, you see, I'm already screwing up. So like it's not an indicator of skill. It's just like, hey, I might need a little bit more time to process the information and do something with it. But like, to me, this is fine. This is okay. This is whatever. And then you have the people who, I guess, I mean, I don't say me because again, I do this terribly. That's like level 18, and this is tournament level, Tetris. You're playing at level 18. You're playing at what the pros play at when they play.
Mm-hmm.
So
Yeah. So we should document all of this, but I think it would be helpful, to kind of describe what, via either Figma mockups or just like, kind of a description of what data we want on there, like available to the players, what both the spectator should be able to show folks, and the commentator should be able to show folks about the game, and what what would be helpful for the coach to provide, and like how to potentially segment the players and stuff. Write it down.
I had an idea about like, so textual there's a textual like demo that's a chat bot.
Mm-hmm.
In my mind, I was thinking like, oh wow, you could use something like textual to be like a secondary console that is sending messages, almost like a Minecraft style chat window. It's like, hey, enter your name. Cool. Waiting for game to start. All right, the game has started. And then as you're playing, it's like, turn whatever. This happened. Good job. Start trying to clear. Like, that's fine. Try to clear this line. So then, like, you're finding those, like you said, anomaly detection. So hey, Tetris readiness went from 0 to 1, or 1 to 0, went from true to false, and then from there, like that sends a signal through, like, is it Event Hub, to say like, all right, one, change the stoplight, but also put a message in the textual console that says, hey, you covered your well, no big deal, you should be able to clear this up in a couple of moves. Hey, what are you doing? You're adding more weight to the well. Try not to do that. Oh dear, abort, and then like that's when like the light is turning red. So, and I think you could even use the light to signal, like we have what is it? Is it Notification Center, or maybe it's just using like Signal R to do like, hey, send a pulse on the stoplight just to indicate like, hey, coach has something to say. And like that could even be like a quick visual cue of like, oh hey, something changed, but also like whoever is watching it, they can see that, look down at the chat box and say, oh hey, yeah, the coach said good job clearing that up with a smiley face or whatever, and you just go from there.
These are all good ideas.
Okay.
Let's make some examples, and then
I'm writing that down now so I don't forget.
Yeah.
IoT.
That feedback about like red, green, red, yellow, green, whatever, would have to be as fast as possible, right?
Yeah.
Okay.
And I think that's why you do it that way, is because you can test for, did you close the well easily. There are some things that we can do outside of the model to say like, hey, we're gonna capture what the board state is and use that to determine basic things. And if those basic things have happened, go ahead and send a notification to the board. But then maybe that's a way you ping the model to say, hey, can you give me feedback about the last, the previous 5 plays and the next 10 or whatever. And then have the model send back some form of dialogue on that.
What
or
would
is that too
what
complicated?
I don't know. I was just trying to research like what latency different services have here. What would be too much latency, do you think?
in terms of sending the light or sending the message?
If you are playing and you need to see this information, how, because like you will continue playing.
With
I mean, ideally you would know a couple of pieces.
Yeah,
okay, so
and,
not
I mean,
like a
that's-
couple of frames.
No. I think at most, and perhaps there's a way to cheat this too, is if you're sending several frames down, you can detect an issue before the piece is final, just based on their location. So like if I know the piece is dropping at a certain rate, at a certain point parts of the board are going to be closed off. So if the quote unquote optimal placement was within that area, then you should be able to get that information to them almost as the piece drops, or within like the next piece dropping. And the reason I think that is because you have enough information to have, this is when, so at any given time you have the current piece, the board state, and the next piece.
Mhm.
So you can already be identifying where you're going to place the next piece off of all of that information. Not even your current piece. You can identify all the places you could put the current piece, but you can start planning for where you would put the next piece.
Mhm.
And then once you have those options, you then eliminate based off of where the piece actually went. And I think you can start cutting off those options as the piece is dropping. So if you're doing it like on machine frame by frame, you could say, okay, it's halfway down the board, eliminate if the piece is all the way to the right, eliminate everything on the left side. There's not enough time. So now I just have this array of options. And then, okay, the piece is finally down. It's here. I now have these models to stem off of, and I can start working on the future piece after that.
Yeah. So I think based on the way you described that, a genetic algorithm would be kind of ideal for that. I can write up exactly how that works. But when you are talking about a bunch of different options or paths that it could take, and you want to kind of like effectively model what each one of those would do, and then in the end select the best one or collapse it, as you say, because the piece did end up somewhere.
Yeah.
Now, based on that, let's make a new generation of options. Like it's supposed to be like evolution. So like you make a bunch of different options. You can do this sometimes in combination with trained models. So like, but like trained machine learning models for stuff. Popular examples of this would be like reinforcement learning on like playing Flappy Bird. So that's kind of or playing Super Mario Brothers or whatever knockoff is required. But yeah, I'm not sure that. Yeah.
Given that we know that the pieces are pseudo random, I don't want to say random, they're pseudo random. Could we create not necessarily like gameplay learning data, but can we create like scenarios based on that information in the X arrays?
Maybe.
Because I think that's not to say that's how you would train it, but I think that if you need data, like the data doesn't have to be people actually playing the game. If we know what the desired state is, and we know, because the problem that I have is there's not going to be a lot of examples of people playing level 0 Tetris at an efficient rate. So you have to then say, where are we getting that data to learn from? Like if you want level 18 data, like we got that for days. There's plenty of YouTube videos that we can look at that just do that. If you want 15 data. Like 15 data is probably a little bit harder, but we can find it and like we can get it. But I think some of that would have to be synthetic, and then like level 0 data would almost all be synthetic because nobody wants to put down like them playing at level 0. No one's streaming that. Sorry. No one at a
Raffle,
large
I
enough
can produce
scale.
that.
I mean, yeah, let's get you an NES and then like we'll have you cover that. We'll have Joseph cover the 15 data and then I'll cover the 18 data. And it'll just be like, yeah, this is how you play Tetris. Not that great, but this is how you play Tetris.
But I mean, that's the thing is if it's a model for you as a player, you don't have to include gameplay at levels you don't play.
So could you start from 0 then and say like we don't have any trained, like we don't have any data to train off of? We're just saying like you start with the assumption of I know how many frames I get per decision. I've made those decisions. I've done those moves. I've done all the generational stuff, and I've started weeding stuff out. Every time I lift my hand up, my watch light goes off. I'm like, okay, stop. I'm gonna like turn my hand this way. Um, but like, can you do all of that and just say we don't have a model? Like, we don't have any trained examples of what you should do. We just have we've identified what X-ray could be or guess whatever our system is looking for in X-ray to define certain scenarios.
Yeah, I mean, that's kind of usually how generative algorithms start. You have the two things you need are a fitness function.
Okay.
So that would be basically a way to assign a numerical value to the success of each child. So, like, in this case, the children are like possible piece placements.
Yeah.
So, if you could say, like, super high value completes a Tetris, high-ish values for completing a line, like that would be the like logic where a player like yourself or overall strategies would need to define what the fitness function is. And then you'd have to have some sort of starting state, but that's easy. Just
Okay.
make it like, or start with uniform random. I don't know. There are many different paths there. I do have to go kind of soon here.
But... Yeah, StreamYard is yelling, my connection is going unstable, so I guess that's a good indicator of like, hey, we should probably wrap this up. But this was good. This was actually a good session. And I think for me, I'm going to take that class model that you made and I'm going to flesh that out a bit. And again, once you have an example of what it'll look like in X-ray, I will just take that and like synthesize it. Like, okay, give me this array. This is what left well looks like. This is what center well looks like. This is what right well looks like. Find these things. And then give them, like you said you need labels. So I can assign a label to like all of the different Tetris terms that I know. And then I can also start working on interface mockups for the commentator.
Okay.
Or I guess the commentating coach. And again, I think I'll just use textual for that and say like, hey, create a rich console and like have some like windows that say like, oh, Tetris ready, big like yes or no, how many lines, score, all that stuff, number of Tetrises, that whole shebang.
Yeah, no, I think that would be great.
Okay.
Yeah, one last question, which was you mentioned that all the professional folks who are like using those tools that like just capture the move, they're not playing on like consoles per se, they're playing these. Are those recorded games somewhere? Like, is that data available that's already digitized?
You mean like, wait, so are you asking like the gameplay from professionals?
Yeah.
Yeah, that's all over YouTube.
But like not in video format.
Oh, is the raw game data available? I don't think so. Because what they're doing, in most cases, is they're playing on their actual console, and they're streaming it to a channel that is doing what we're doing. It's overlaying the data and then presenting more information. And it's doing things like color correction, like obviously people on different screens, different, uh, HDMI converters and stuff. Like it does its thing. So it's doing all of that, and it's giving you the video, but it's like on like a 15-second delay, and
Mm,
then it's basically just replaying the game as it's happening.
right.
And I don't think Max Out Club makes like, I don't think they store any of that information anywhere, or at least I don't know if they do, and I haven't heard of anybody talking about it.
I want to make one other issue because I think it would be useful to just check on that because that would be beautifully helpful data. Or even if they have, I mean, sounds like they probably don't have open source tools, but if they had open source tools for some of the stuff that they use to create those overlays, that might be interesting to look at for prior art.
I can see if Max Out Club is on GitHub at all, but I haven't seen anything. And it was like, I think when I was originally looking, I don't even think I was looking at that. Oh, it does have a GitHub. Sweet. Oh, that's just Tetris Gym. That's not Max Out Club. Tetris Gym isn't going to work because it's like a ROM basically. So you would need an emulator, and you would need to like build out a Tetris game in an emulator. And yeah, there's some. I'm not gonna say that it's illegal. I'm saying I don't want to deal with Nintendo.
No, and that's fair. I guess it seems like some of them would have to, because like some of the projects we looked at, they implemented a Tetris like game, in the browser, right? They wrote it with inputs.
Mm-hmm.
You could quite logically record those from the web pages directly,
Mm-hmm.
and then just have a log of whatever sorts of game state sorts of things from that web page. So my question is, are there instances of this where like you could basically get people to play it and capture that recorded data directly without having to do any of the screen parsing as just additional data to train? Because once it's digitized, like whether it comes from the okay, I get the
once it comes from anywhere, it exists.
Yeah.
There's so JSTRS itself, it might have something. I don't fully know.
I made an issue, so we can look into that. But
JSTRS is about 800 lines of code. That is like the entire deployment of stuff coming down, of like, hey, blocks falling and all those things. So like that's a thing, but again, that is literally how the game functions. I don't know if it's grabbing things. But there are plenty of AIs that are like Tetris algorithm implementation with JSTRS as a simulator.
But like the simulator state has to be stored somehow to be displayed, right?
You're saying like in the algorithm?
Or whatever's like, if the simulator is,
they may
like, if there's a simulator
for that,
right? So like one interesting thing one could do to get training data is to make a web app that hosts a specialized version of JSTRS that basically automatically logs the output of the simulator, which would be the game state data basically directly.
I think I see what you're saying.
And generate training data that way. Now, it is not in the spirit of like what we're trying to do here with the coaching. That would just be perhaps an interesting side related thing that would be great for like public, like folks could help us as we were doing this. Like they could go to the web app, say I'm a beginner, I'm intermediate expert, play the game. We'll capture that data and use that to help train models associated with those skill levels. Anyway.
Yeah, I think that'll work. There's some like technical questions in there that are interesting, but if you haven't captured, then I think it's good. This has been fun. We should do this again.
Definitely.
I don't know when, but we should do it again. For folks that have been watching, thank you. For folks that will watch this later, again, thank you. If you want to help out, I did not put it in here, but I'll put it in the description on YouTube. But it is a public repo. If you want to get involved, you are more than welcome to. All we ask is follow the code of conduct. That is not the URL because my GitHub account is not a part of that. Let me do this. There we go. That's the URL. This has been fun, Sarah. I will chat with you later.
See y'all later. Bye.